Welcome to the next session, my dear friends. In the previous session we have discussed about the mechanisms of filtration. Now we are discussing the filters one by one. This is the schematic view of a slow sand filter. Slow sand filter. So this is a slow filter having sand as a filter media. That is why we call this as slow sand filter. Here the rate of filtration of this slow sand filter, the rate of filtration of slow sand filter is equal to 100 to 200 liter per hour per meter square. Liter per hour per meter square surface area it will filter. Okay, here if you look at this diagram, the water will come from this inlet. This is the inlet. So this is a column where you will store the water. Once it reached the sufficient level, then we will allow this water into the filter media. Okay, we will allow the water into the filter. This is water. This is raw water. And now this raw water is mechanically strained on this sand. This is filter media. This is filter media, and the thickness of this filter media is 90 to 100 centimeter, approximately 1 meter. Approximately it is 1 meter. And below this the filter media of sand, there is gravel. So gravel will be having approximately depth of here the sand media depth is approximately 90 to 110 centimeter, whereas the sand, this gravel is approximately 30 to 75 centimeter. It is approximately 30 to 75 centimeter. So here gravel is present only to support the sand filter media. Gravel does not act as a filter media here in slow sand filter. Here the gravel layer or gravel bed acts only as a support to filter media. It does not participate in filtration activity. It does not participate in filtration activity. Very, very important. And after the water passing through this sand media and gravel media, it will enter into a under drainage system. This is under drainage system. This is under drainage system. So we will discuss clearly what is under drainage system, what are the components of under drainage system, what are the design parameters of under drainage system, and how to design the under drainage system separately. Now the water from gravel enters the under drainage system. From this under drainage system, the water will enter into this chamber from where we collect the water into the outlet. This is outlet. So then this water will go to the next treatment process. So there are some specifications that are present for this filter media. So let us see the specifications of the filter media. Specifications of filter media. Not that important for gate, but they may ask the comparison between the filter media specifications of slow sand filter with rapid sand filter. Like that they may ask. That is why comparisons are important, values are not that important. We will establish a comparison between all the specifications of slow sand filter with all the specifications of rapid sand filter. Once we completely learnt about the slow sand and rapid sand, after that we will establish a comparison of all the specifications. That is very important for GATE examination. Now the specifications, just for the sake of knowledge, we will see all the specifications of the filter media. The depth of the filter media, total depth of the filter ranges from 2.5 to 3.5 meter. Total depth, it's not filter media depth, specifications of filter, rather we will take it as specifications of filter, including filter media also. This is depth of the filter. And the plan area of filter will be very large, approximately 100 to 200 meter square, 100 to 200 square meters, very large plan area. Sometimes it is not 100 to 200 meter square. Very large plan area is needed to construct this filter. Okay, and next is D10 of the filter media. D10 is 0.2 to 0.3 mm. D10 is what? Effective size of the filter media is 0.2 to 0.3 mm. And D60 by D10, that means coefficient of uniformity. D60 by D10 is equal to 5. So these two are for filter media. These two are of filter media. These two belongs to filter media. Okay, D10 and CU, coefficient of uniformity, is 5 for filter media. So here I already told you the gravel acts like a supporting material only. It does not participate in any kind of filtration operation, but whereas in rapid sand filter, this gravel also takes part in filtration. In rapid sand filter, this gravel media also takes part in filtration, whereas in slow sand filter, it does not take any kind of filtration. It will not take any participation in filtration. That is very, very important point. Next is operation procedure of filter. How this filter works, I already told you. So again we will discuss it elaborately, how this filter work. See, all the filtration takes place at the surface of the sand. Mostly it happens at the surface of the sand. Okay, so once after some time, during the usage of the filter, the sand, whatever the impurities are completely will settle on the sand. Whatever the impurities present in the water are completely take the top portion, surface. So there will be a surface of impurities will form on the top of the sand. So we need to remove it. Otherwise what happens? It makes, if you don't remove it, then it will make filter unfit for during any kind of filter operation. It will not allow any kind of filter operation. Okay, so generally the loss of head of filter varies from 5 centimeter when it is clear to 90 centimeter when it is completely having impurity. See, the head loss varies from 5 centimeter to 90% of the depth of filter media, that is approximately 90 centimeter. Okay, so head loss varies from 5 centimeter to 90 centimeter. Why 90 centimeter? I will tell. 5 centimeter to 90 percentage depth of the filter media, that is approximately, it is 100, approximately 100, then it is 90. Okay, so this is the head loss variation. So when it reaches to a head loss which is equal to 90 percentage depth of the filter media, then we need to keep the filter for servicing, maintenance. Okay, when the head loss reaches to 90 percentage depth of filter media, then the filter is taken for maintenance. What is maintenance in filter? What is maintenance in slow sand filter? The maintenance in slow sand filter is nothing but removal of top 15 to 30 mm of the sand. Removal of top 15 to 30 mm layer of this impurities, that is nothing but removal. 1.5 to 3 centimeter or 15 to 30 mm of top layer which is containing full of impurities will be removed and relaid with new filter media, new sand. Okay, so during maintenance, the topmost layer of about 1.5 to 3 meters, 3 centimeter. Topmost layer of 1.5 to 3 centimeter is removed and relayed with fresh media. So this is how we do the maintenance of the slow sand filter. After resumption, so once the maintenance is over, after resumption of this filter media, we don't consider the water which is coming after removal of this filter media as filtered water. After the formation of this Scimitar decay, we don't consider the water as a filtered water. After that we do it. Okay, after that we do it. So here, for cleaning this topmost layer, of topmost layer, we use only filtered water. Generally, anywhere you go, we will clean the filter with filtered water only. During the maintenance, we remove the topmost layer of 1.5 to 3 centimeter and the rest of the filter media is cleaned. So here, during the removal of the top layer, we clean it with some water. So the scrapping will be done again by using water. If you are using water for the cleaning, that water should be again filtered water which is coming out of this filter, needs to be used for the cleaning and maintenance of the filter. Generally, this cleaning is done for once for every 1 to 3 months. Then the cleaning is performed once in 1 to 3 months, or when the head loss reaches 0.7 to 0.8 times of filter media depth of filter media, whichever is earlier we do that either once in 1 to 3 months, or when the head loss reaches to 0.7 to 0.8 times of depth of the filter media. So this is all about the slow sand filter operation principle. And this slow sand filter is not used when NTU is greater than 50 ppm. That means slow sand filter is not effective. So this slow sand filter it is not used when turbidity is greater than 50 NTU. 50 NTU. It is preferred when the turbidity is less than 10 NTU. It is preferred when the turbidity is less than 10 NTU. When the turbidity is less than 10 NTU. So highly turbid waters we don't send into the slow sand filter. We will use different kinds of filters such as rapid sand filter, pressure filter, or dual media filters. We use those filters for highly turbid waters. Okay, so this is all about the slow sand filter. Let us discuss about the rapid sand filter. After discussion about rapid sand and slow sand, we will discuss the design of filters. Design of filter is very, very simple, very easy if you understand the concept. So rapid sand filter generally operation is difficult. Slow sand filter operation is very easy. Just send the water onto the filter media. The water will go under gravity. Again, I forgot one more point. Slow sand filter is a gravity filter. Even rapid sand filter is also gravity filter. One more point we can add in slow sand filter, that is, it is a gravity filter. This is now rapid sand filter. So it is a rapid filter having sand as a filter media. The rate of filtration, it is around 3000 to 6000 liter, 3000 to 6000 liter per hour per meter square. That is 30 times of ROF of SSF. 30 times the rate of filtration of slow sand filter. Okay, that is the rate of filtration of rapid sand filter. Here in rapid sand filter, I will draw the schematic diagram. Here there will be different valves. There are different valves that will be present in rapid sand filter. We need to understand when we need to operate which valve. That is very, very important here. So let us see the figure, schematic diagram. These are the troughs where we load the water. So from this trough the water will enter into the rapid sand filter. From this trough the water will enter into the rapid sand filter, and now whatever the water which is entered will come onto the filter media, that is sand media, and then it will enter into gravel media. And below the gravel media there will be under drainage system. Below the gravel media there will be under drainage system. So this is under drainage system, and there will be the filtered water. So whatever the filtered water which is coming out of this under drainage system will be collected, and some amount of filtered water will be sent into a storage chamber. Some amount will be sent into a storage chamber, and at the same time we will derive the water. We will take back the water from this storage chamber also. This is just a schematic diagram, okay, not to scale. So I want to tell what are the different components that are present inside this rapid sand filter. Okay, what are the different components that are present inside the rapid sand filter? Here there will be number of valves that are present in the rapid sand filter. Let us see what are the different types of valves that are present inside the rapid sand filter. Let us see what are the different kinds of valves that are present inside the rapid sand filter. So here, this is valve number 1. Here, this is valve number 1. Okay. This is valve number 2. And this is valve number 3. So from here there will be valve number 3. And this is valve number 4. And this is valve number 5. And here this is valve number 6. So valve 1, valve 2, we indicate valve like this. We indicate valve like a cross symbol. Okay. So we indicate it like this. So valve 1, valve 2, valve 3, valve 4, valve 5, valve 6. There are 6 valves here. Okay. Each valve is used for different purposes. Each valve will be used for different purposes. So let us see what is the purposes of each and every valve. During the filtration process, during the filtration process. See, the water is allowed from here, valve 1. So this is inlet. Okay. So during the filtration from valve 1, we will allow the raw water to enter into the filter. Okay, rapid sand filter, and the water will enter the sand media, and then it will pass through the gravel media. It will come into the under drainage system. From under drainage system, it is collected in a common pipe, and from this common pipe, it is allowed to pass through the valve number 4, which is filtered water. This is what? This is filtered water. So to collect filtered water, we keep the valve number 4 open. So during filtration process, valve number 1 and valve number 4 is kept open. Now, after some time, the filter media completely exhausted. So we need to maintain the filter media. We need to clean the filter media. Now at that point of time, we will not send any more raw water. So we need to close valve number 1, and there won't be any filtered water now. So we can close valve number 4. So during maintenance, valve number 1 and 4 is kept closed. Now, I told you, so during the filtering process is going on, some amount of water we will store it for the purpose of cleaning of filter. See, generally cleaning of rapid sand filter is performed by backwashing. Whereas in slow sand filter, it is performed by scraping of top layer. So in slow sand filter, we will scrap the top layer, but in rapid sand filter, we do backwashing. So during the backwashing process, we keep valve number 1 and valve number 4 closed, and we will open the backwashing valve, that is valve number 5 and valve number 6. Again, backwashing is of two types. One is high velocity backwash and another one is slow velocity backwash. So high velocity backwash. So here from valve number 5, compressed air will come. Valve number 5, we will send compressed air. So this is air valve. Valve number 5 is air valve, and valve number 6, we will send the filtered water. Here we will send the filtered water. So this is water valve. This is what? Water valve. This is water valve. This is air valve. So again, backwashing is of two types. Backwashing, it may be high velocity backwash, backwashing, and slow velocity backwashing. slow velocity backwashing. It is high velocity backwashing and slow velocity backwashing. In high velocity backwashing, only water is used. Only water is used. So that means only valve number 6 is opened in high velocity backwashing. In slow velocity backwashing, water is sent along with compressed air. Along with compressed air. Along with compressed air. So that means here in slow velocity backwashing we keep valve number 5 and valve number 6 both opened. Okay, so backwashing is of two types. In high velocity backwash we open only, in high velocity backwash we open only valve number 5, valve number 6. In slow velocity backwash, water is sent along with the compressed air, so that means we will open both 5 and 6. In high velocity backwashing, valve number 6 is kept open. Whereas in slow velocity backwashing, both valve number 5 and 6 is kept open. Now, so you are sending the fresh water through the gravel media into the sand media. Now whatever the impurities present inside the sand media and gravel media are coming out into this troughs. Now from this trough, earlier the movement of water was like this. But during the backwashing the movement of water is like this. And now, so this is the movement of the wastewater. Now this wastewater will enter into this zone. Okay. Once the cleaning operation is completed, so whatever the wastewater coming out of the troughs, is collected into a gutter. So the wastewater, so during backwashing, the wastewater coming out of the troughs, is collected in a wastewater gutter, by opening valve number 2. See, whatever the water comes now will go through the valve number 2 and comes into the wastewater gutter. This is wastewater gutter. So now whatever the water which is coming out of this washing will enter through the valve number 2 into the gutter. So now during the backwashing, if it is a high velocity backwash, valve number 6 will be opened and valve number 2 will be opened. And if it is slow velocity backwash, valve number 6, valve number 5 is opened for backwashing, and after that whatever the wastewater that comes will be collected from the valve number 2 into the gutter. So once the backwashing is completed, okay, once the backwashing is completed, so valve number 5, valve number 6 and valve number 2 is closed. Once the backwashing is completed, once the backwashing is completed, valve number 5, 6 and 2, 5, 6 and 2 will be kept closed, will be kept closed, and after this we will start allowing water. Now we will start allowing the water. So we will start allowing the water now. So for sending the water, so after backwashing, these 3 valves will be closed, and to resume the filter, valve number 1 is opened after completion of backwash, and the filter is loaded with raw water, but valve number 4 is not open. See, now valve number 1 is opened, the raw water is loaded, and the filtering is taking place, and the filtered water entered the under drainage system. From this under drainage system, we will take this water to the valve number 3, through the valve number 3 into the wastewater getter. Okay, so filter is loaded with raw water, but the filtered water is not considered as filtered water until the formation of dirty skin, and hence the filtered water is diverted into wastewater gutter by opening valve number 3, So that is why even after completion of the backwashing also, until the formation of the dirty skin, we don't consider the water which is filtered, that is as a filtered water. That is why whatever the water you are collecting at the under drainage system will be directly sent into the wastewater gutter from valve number 3. Let us just have a recap of what we have discussed. See, first, during the beginning of the operation of filtration, we will open the valve number 1 and we will load the filter, and the water will go through the sand media, filter media, and gravel media, it enters the under drainage system. From the under drainage system we will collect the water from the valve number 4, that is called filtered water, and some amount of water we will divert into this storage tank which we use for backwashing. That is first. Once the filter media is completely clogged or filter media needs maintenance, then valve number 1 is closed, valve number 4 is closed, and depending upon the type of backwashing, whether it is a high velocity backwash or slow velocity backwash, accordingly we will open 5 and 6. So if it is a high velocity backwash, only 6 valve is opened. If it is slow velocity backwash, then we will open both 5 and 6. 5 is the valve which sends compressed air, 6 is the valve which sends the filtered water again back for backwashing. And now once we send this through the filter media for backwashing, the wastewater will come onto these troughs, and from this troughs it enters into this chamber. And now from here, so in order to send the wastewater out of the rapid sand filter, we will open valve number 2. So after opening 5, 6 or 6 alone, we will open the valve number 2 to take the wastewater into the wastewater gutter. And once this backwashing operation is over, then we will close this 2, 5 and 6, and we will open again valve number 1 for resuming the water filtration process. Now the water again filtered as usual. Earlier what is happening, similar in that way, in the similar manner it happens, but here up to the formation of the dirty skin we don't consider the water as a filtered water. That is why again the filtered water we will send into the valve number 3. So and we will send that into also into the wastewater gutter. Once the scummagica is formed, then we will send the filtered water through the valve number 4. This is the total operation procedure of rapid sand filter, and in the next class we are going to discuss the design of the filter and design specifications of rapid sand filter. What is the depth of the sand media, gravel media, specifications of this filter media, specifications of the filter, design of the filter, everything we will discuss in the next class. And also design of the under drainage system also we are going to discuss in the next class. Thank you so much.